Second term in an arithmetic sequence is 1, and the third term is 4. The first term is f of 1. Okay, so they want us to make a table, but in this case it's going to be n and f of n. Okay, sure. First term is f of 1, so let's find out what that is. Which is an equation for the nth term of this sequence? Okay, just have to write the equation. The second term is 1, and the third term is 4. The common difference, excuse me, how do I get from 1 to 4 is I add 3. So how do I work backwards? I'm going to subtract 3. So my first term here is going to be negative 2. So if I'm substituting this into the formula, I get a sub 1 plus, d times n minus 1. So now I have f of n is equal to, the first term is going to be negative 2 plus 3 times n minus 1. So I'm going to distribute the 3, and I end up getting f of n is equal to negative 2 plus 3n minus 3. I'll combine the like terms here. I'll get 3n minus 5. That is choice 2. Explain how you can find your answer by using your calculator or by working backwards. So we worked backwards here by subtracting the 3. Question 5. The third term in an arithmetic sequence is 31. And the fifth term is 47. If the first term is a sub 1, which is an equation for the nth term of this sequence. That means just write the equation. Okay, well, we got to figure out what the common difference is. This is arithmetic, so it's a common difference, right? I'm going to do the change in y over the change in x. So it's going to be the change in y, and that's going to be 47 minus 31, which is 16, over the change in the x's, or the term numbers, 5 minus 3, so that's going to be 2. So the common difference is going to be 8. So the common difference is 8. We got to figure out what the first term is then. So if I add 8 to get here, of 39 plus 8, yep, that works. And then to get backwards in this way, right, to get to the second term, I'm going to have to do 31 minus 8 now, and that's going to give me 23, and then minus 8 more. It's going to give me 15. Okay, so a sub 1 is 15. So now I plug this all into the formula. I have 15 plus 8 times n minus 1. And it looks like they expanded this out kind of. So I have a sub 1 is equal to 15 plus 8n minus 8. I combine these two. 15 minus 8. That's going to give me 7. So I got 8n plus 7, which is going to be answer choice 1. Okay. Excuse me, I'm sorry for all the yawning. Okay, question 6. Are there more of these? No, we're good. Okay. Question 6. Tim made $50,000 in the first year of employment and made an additional 3% each year. Ooh, an additional 3% each year. Use a geometric sequence to find the amount of money he made in his 7th year of employment. Ooh, okay. So his 7th year of employment. Well, I think I'm going to make a little equation. Sorry. And I have a multiplier of the 3% growth. Since it's growth, I'm going to be adding it to 1. And then this is going to be to the n minus 1, okay? So use a geometric sequence to find the amount of money he made in his 7th year of employment. Well, let's think about it, right? So if I have a sub n is equal to 50,000 times 1 plus 0.03 to the n minus 1. Well, n can't start at 0, because if it started at 0, it would be to the negative first power, so that doesn't make sense, right? So the first year is going to be n equals 1, or that's the start, right? And then after the first full year has passed, it's kind of technically like year 2, right? So if we took that 1 and we put it in here, we would get our 50,000. So this is going to be at the end of year 1. This is technically kind of year 1, right? So I've got year 2 is going to be 3, year 3 is going to be 4, year 5 is going to be 6. So year 6 is going to be 7, and then now we're trying to get to the 7th year. So year 7 is going to be 8. So I'm going to have to evaluate this thing for when n is 8. The only reason I'm doing this and not just like a plain old exponential is because it says I have to use a geometric sequence, which is kind of sneaky. What am I supposed to round to? Let's just round to the nearest dollar. Okay, that's it.